Hey everyone, in this video we'll use another couple of functions in the Tidyverse. The first thing we're going to do is look at the pipe operator. And the pipe operator isn't a function per se, but it's more about making your life easier and making your code easier to read. The other thing we'll look at is a way to change our data set from wide format into long format. And that's by using the pivot function. So it's either pivot longer or pivot wider. Okay, so let's get right into the R screen right now and get to it. All right, so here we are in my R screen. And the first thing we're going to do is we're going to load the Tidyverse library because we're going to need to use some of the functionality included within that. So we do that by using the command library Tidyverse and running that command enter. So we see that it's ran that and it has given me a few check marks here that those packages are loaded. Excellent. So the next thing I'm going to do is we're going to set up a scenario. So this is going to be based on the mindfulness data that we've used previously. So let's, in fact, import that data into our R environment right now. So we could, again, use that by import that by using the import dataset or by using text command, but I'll just do it using import dataset this time. From text, I'm going to go into my data folder and I'm going to scroll down and find my mindfulness data. So that's right there. I click on open and I'm going to let it be called mindfulness. And I want to make sure that it knows that it has headings. So I'm going to say, yes, there's headings. That way, if I say no, it's going to show me that I've got these variables called V1, 2, 3, 4, 5, and I want them to be called their headings there. Otherwise, I'm going to just click on strings as factors just in case I need to use the different strings as a grouping variable like male and female. And I'm going to click on import. And we see that it pulls up this mindfulness data set and I've got it inserted here. The other way we could do that, remember, is to use the read.csv function, but you can look at our other videos to find out how to do that. So in this scenario, I'm going to put down in here, what if we only wanted the columns of summed scores? And that would be summed scores across mindfulness, stress, and depression, as well as maybe age and gender. And that would be our data set, rather than just all those raw variables. Well, one way we could do this is we could create what we call throwaway data frames or temporary data frames. But as you'll see as I go through this, this gets a bit messy and it's very easy for you to get sort of lost in what step that you're in if you do it this way. But this is one way you could do this. So I've loaded up the mindfulness data set, and the first thing I'm going to do is I'm going to place the mindfulness data frame into a temporary data frame that I'm calling DF. So this is really just copying it. So we can see these are exactly the same thing. I've just copied that data frame into a new one. So I can manipulate that data frame. Then let's say, okay, so we want some scores and we only want people older than 18. So the first thing I might want to do is filter on age being greater than 18. So I could go, okay, DF2 is filter DF, comma, age is greater than 18. And now what we'll see is that's narrowed it down. And we should see that if I open up that data frame and look at ages, I've only got people older than 18. Scroll that down, yep, 18, 19, 20. So that worked fine. Okay, so the next thing is we want to have only the summed scores of columns. So let's see how we could do that. And then I'm going to create another temporary data frame in which I'm going to create the new columns. So a mind sum column, a stress sum, and a depression sum. So we do that by using the mutate function, which allows us to do a calculation. So we're going to mutate, and it's df2, and I'm going to create a new column called mind sum. Let's do that, mind capital sum, equals row sums, and I need to select from df2 anything that contains mind. Okay. And then in addition to that, I'm going to do a few more of these exact commands. So I'm just going to paste that twice. So I'm going to have select df2 contains mind. Then I'm going to do a stress sum. Oh, I spelled that wrong. Row sums. Better do it in all three places that I screwed that up. Row sums. All right. Stress sum is going to be row sum select from df2 contains stress. And dep sum will be row sum select from df2 if contains dep. And just make sure that I've got all of those brackets closed. Okay. And then after that, I can select the rows that I need. So I'm going to make a new data frame, so which is df4. And that's going to be select from df3. And I'm just going to say I want for example, gender, age, mind sum, stress sum, and dep sum. All right. So we can see what happens as I ran the second command I've got there. I just need to look up to make sure which ones I had to run already. I can run the third one. That should give me everything over here with my sum scores. Okay, that's pretty good. And then the last one I need to do is select the correct columns that I want. So let's see if that worked. So df4. And that looks good. So I've got gender, age, and then my 3 sum scores. Whew. Okay, so that seemed like a lot, and I created a lot of objects in the meantime. So that could get messy, and you could mess up where you were. If you don't run one of these commands, you could get kind of lost and whatever. So possibly a better way is to use what's called the pipe operator. And we can think of the pipe operator as basically meaning and then. So I'm just going to paste this here. The pipe operator looks like this. So it is % greater than %. And you can think of it meaning and then, and we can create it using this shortcut, Control-Shift-M. So you can see that if I hit Control and Shift, or for you Mac people, Command-Shift and M, it creates that single operator. And I'll show you how we use that. So imagine that we want to do the same thing that we just did. So we can say, okay, into a temporary, so let's get rid of these data frames first. I'm going to get rid of all my temporary data frames. Yep, gone. Okay, now into df, I'm going to do all these same things that I just did. So I'm going to take mindfulness. Oops. And then I go Control-Shift-M, and then I'm going to put this on a new line. Okay, so what's the next thing that I want to do? Well, I want to filter age is greater than 18. Now, what you'll notice here is that now I don't need to specify, as I did in the previous one, which data frame, because what it's doing is it's passing the output of this, so mindfulness, into the first argument of the next one. So it's going to say, give me mindfulness as the first argument. So it's going to say filter mindfulness where age is greater than 18. Control-Shift-M. And then I'm going to do this whole thing. I'm going to copy that, paste it. But again, I don't need this first argument because it's actually just passing along all of the things that we had. So I'm going to, and then mutate where MindSum equals these things, these things, these things. At the end, Control-Shift-M. And then I'm going to select, but I don't need to specify the data frame, all of those things there. And then I can be done. So if I run this one command now, I'm only creating one object and it's got all of these different functions in it. Now you could run these and make sure it all works one by one. But here, if I hit Control-Enter, you can see I have an error. And this is actually interesting because I forgot that I had specified df2. I went to select from df2. Now, when we're using a function within a function passed through the pipe operator, so I'm using the select function within the mutate function, we still have to specify the data frame. So I could tell it, for example, mindfulness, or I can just tell it dot. That's shorthand for, well, just give me the one that you had passed through so far. And now, once I've changed all of those to dot, we should see that that actually works now. So when you've got a function within a function, you still need to specify in one spot a dot. So that's why we basically got an error that I was trying to search for an object that it couldn't find, and it didn't work. But basically, running this made it work. Now we can see the thing that I find, or the thing that I see here, I've got the exact same output as what I saw from the previous one, which went through all of these steps to get to the final data frame that I needed, which was the last one that looks exactly the same as this. So the pipe operator allows you just to pass along commands from one to the next. So again, like I said, I took this data frame and then I filtered it, and then I mutated by creating some more columns, and then I just selected those columns that I wanted and passed all of that and saved it into DF. So let's try another scenario. Let's scroll up here. Let's try a different one with the US rent income dataset that's included in the Tidyverse package. So if I want to see what that looks like, I can use the view, and it's US underscore, well, there we go. It popped right up. So I'm just going to select that, Control-Enter, and we can see here we've got some GeoID, we've got a name that's of a state, variable, income or rent, and estimated, and we've got this MOE. So that's margin of error. So we've got an estimate of income and an estimate of rent. All right. So what we're going to do is try and figure out something about this data set. So let's think about one way we want to clean this data set up. Suppose we'd like to find states where rent as a percentage of monthly income is less than 35% from that data set. Okay, so this is going to be a lot of steps to try and figure out. How do we get to that? Because we've got yearly income, we've got monthly rent, we've got all kinds of different things, and we've got them on separate lines. So this isn't going to be an easy one to do. So we could do them using throwaway data frames. We'll do that this time, again, the same way. So we'll create a DF where we're going to copy into it US rent income. Okay, so now I've basically just copied US rent income into that DF. So I've got it as an object up here. Okay, so now I want to maybe select into DF2. Let's just get rid of some of the things we don't need. So I'm going to select from DF. I don't want MOE. So I don't want margin of error. So we can see that I create that. It just removed that MOE from that data frame. Okay, sounds good. Okay, so in step 3, I need to kind of fix this data because the problem is I've got income and rent on separate lines, but I actually need them in separate columns. So in order to do my calculations, I could do it in a few different ways. I could maybe filter out the income and the rent rows and put them in separate data frames, do calculations on those and rejoin them later. Or here, what I'm going to do is actually create a way to turn these into new variables so I can do the calculations all in one sort of way. So we're going to use the pivot function that we're going to show a little bit more in a moment about how we sort of change from wide to long and long to wide format. So this would be a long format, but I want it slightly wider. So the way we're going to do that is we're going to create now a third temporary data frame, and we're going to use the pivot wider function. Pivot underscore wider. And we're going to take df2, which I just created, and we're going to take the names underscore from. It's going to say, what do we want to get the names of the new columns from? And if we look at the df2, which actually I got rid of there, the names from is going to come from the one called a variable. So names from equals variable. And the values that I'm going to put into those two, I need to specify as well. So the values are going to come from estimate. So values underscore from equals estimate. Okay. Now, if I run that and I look at my df3, now what we can see is instead of having, in this case, 104 rows, you can see here, where we've got income and rent and then 2 lines for each state. Now I've just changed that data set to be actually half the number, only 52, which makes sense, 52 states, and income and rent are actually in different columns, which is going to make life easier for me to actually do the calculations. So we could have done that, like I said, in a different way, but that's one way we can do it. Okay, so now that we've done that, we can create our calculated columns, right? So we want to find states where rent as a percentage of monthly income is less than 35%. Okay, so we have yearly income here. So now we've got to create a monthly income variable. So let's create one of those by using the mutate function. So df4, we're going to mutate df3, and we're going to take income, or we're going to create a new column called income M, which might be, which could be short for income monthly. And that's going to be calculated as what is currently income divided by 12. And at the same time, we could also mutate a second column to be percent income is going to be rent divided by income M times 100. So that's going to be rent divided by monthly income, and that will just give us a value between 0 and 1. So I multiply it by 100 to get actual percentage. Okay, now we have a fourth data frame. We'll look at that one again. And now we've got monthly income. So this looks about right. So income for the year is 24,000. It should be about 2,000 per month. And then percent of the rent, where your percent of monthly income is going to be 36 in this one. Okay, so we've done this calculation. Now we've got rent as a percent of monthly income. Okay, finally, the last thing we wanted to do is find out which states where rent as a percent is less than 35%. So how do we do that? Well, let's create a last temporary data set where we basically say filter df4 where percent income is less than 35. All right. Now, I can click on df5 over here, or another way I can do it is just go view df5, and we see that again. Now it's filtered out only those states where rent as a percentage of monthly income is less than 35%. And we see that there's, in fact, 14 states, it looks like, including Indiana and Iowa, Kansas. And I can actually order these if I want just by clicking on this top header here. And we see actually the lowest ones are the Dakotas. And of course, if we look at the highest ones in terms of less than 35, we've got Missouri and Kentucky. Great. So that was a bunch of steps to do that, right? So again, we'll see how we can do all of this just by using the pipe operator. And it really ends up being the same thing. We have to do the same things, but it ends up being cleaner than creating all of these different throwaway data frames. It can get a lot more messy as we get more and more sort of things we have to do. So sometimes it's just easier not to do it this way and to use the pipe operator. And also it makes your code easier to read. So let's do it one more time. df, well, I'm going to copy this, is US rent income. And then remember, if I use the select command, I now don't need to specify the data frame. It's being passed through. So I just need negative MOE. So I'm going to get rid of any of the column that's MOE. And then I want to do this pivot wider function. I'm going to just paste it there. I don't need to specify the data frame. And then I'm going to mutate. Don't need the data frame. And then filter. Don't need the data frame. Okay, so if I run this whole command, now note, this is just one command. I could have put that all on one line as well if I wanted, but it makes it easier to read just by splitting it over separate lines. Now, if I run that command, we get a new df. I can go view df. And it's the exact same thing as we saw before. So df now has those 14 states and all the percent incomes where income as a percentage of, or rent as a percentage of monthly income is less than 35. Okay, great. So that's really how we use the pipe operator. Now, just as a quick aside, R recently in, I think, version 4.1, and I think we're up to 4.2 now, 4.3. R in 4.1 introduced a native pipe operator. So this pipe operator is actually built into the Tidyverse package. And if you see code that has the pipe in it that you get from online or from wherever, most people will be using this because it's been around for a long time and people have been using this operator. But R now has its own built-in pipe operator, and it looks something slightly different. It's this, it's basically the bar, and the bar is basically right beside the backslash on your keyboard. So it's up beside the backspace or delete button on the keyboard, just above the return key. And then it'll be the greater than. So it's kind of similar in that it's not percent forward percent. It is bar, and then this could mean forward. So that's a different pipe operator that you might see as well. The reason I'm bringing this up is because I'm going to encourage you to go to the R for Data Science second edition textbook, and some of the examples I'd like you to go through and some of the exercises I'd like you to take on and try. They use this pipe operator. And it's not going to make a whole lot of difference most of the time. It's just that in some cases, they work very slightly differently, and you probably don't need to worry about those cases, and you could use these two things pretty much interchangeably. But I wanted you to know that these two things are basically interchangeable. So in fact, why don't we retry this command using the new pipe operator? So I'm just going to replace this old pipe operator with the new pipe operator and see what happens. This is on the fly. I've never done this before. All right. So it seemed to work. And my data frame, it did the exact same thing. So you can see that the pipe operator in this case worked essentially exactly the same. So like I said, I want you to know that it exists and that you can use them pretty much interchangeably. So I'll just put a note in here that, that looks like a / but that's okay. Another type of built-in pipe operator. FYI. Okay. So the next thing we're going to look at, and we really did have a look at this already, is using some more pivoting functions. So dplyr can be used to change from wide to long or long to wide formats. And we actually just did one where we actually made the data frame actually wider because we wanted to do some calculations on it. But a lot of the time you might get a data set where you've got maybe different time variables or different variables in different columns where you need them for R to be in a single row. So a variable might be sex that's got male and female in it, and you need to have that all in one column instead of having values, for example, height for males in one column and then height for females in a separate column. That will not work well in R. So I'm going to show you how to use pivoting in dplyr and R to be able to deal with your data sets when they come in looking like that. So the first one is for one variable with several levels. So we're going to use a data set that you can find linked or on Brightspace. And it is called RTs_wide. So we're going to load that into an object called RTs, which means reaction times, wide. And so it's in wide format. And into that, we're going to do read.csv. For me, I put it in my data folder. So it's going to be data, and it's called the same thing, RTs_wide.csv. And typically after that, I put strings as factors equals true. Strings as factors equal true. That is just a common thing that I will put into mine because I usually like to treat string variables as factors, but you may not want to, but I do that because it makes my life easier usually. So you see that if I do that, if I've put that in correctly, I should get an RTs wide object up here in the top. And I can have a look at that. I can go view RTs wide. And we can see it's basically got some variable called X, and it's just looks like a subject number or something. And we've got RT_dist1 and RT_dist2. So it looks like two reaction time distributions. Okay, so the problem is, say we wanted to essentially say, well, this is reaction time that is associated with a control condition, and RT_dist2 is reaction time that's associated with after people have had caffeine. So maybe a cup or two of coffee. So we need to try and make this data set much easier to read and to understand. So the way we want to do that is to create a new variable that basically is going to be called, group. So caffeine or control, I guess. And then we're just going to stack those values on top of each other. So I'll show you how we actually want to do this. We're going to, let's delete our old data frame here. Let's create a new one. I usually use df just to signify that it's a temporary data frame. So that's not going to be anything final, but something for a working data. Then I can actually write that into some variable or some kind of object that I want to keep. But usually something I call as a temporary, I know that it's a data frame, I'll put it into df. So one of the things that I want to do here is rename my columns. So one way to do that is by just using the rename function. So noted that my RT names were RT_dist1 and RT_dist2. Well, I'm going to rename those where from RTs_wide. So remember, we usually start with the data set. And then I'm going to tell it control is going to be what RT_dist1 was. And caffeine is going to be what RT_dist2 was. All right. Now, note that the order of this is going to be new name and then what was the old name. And usually it's sort of the same as this. RT_dist1 is going to go into control. RT_dist2 is going to go into caffeine. Saying caffeine is going to be equal to what that was. So if we look at what happened with my data frame now, we can see that instead of being called RT_dist1 and RT_dist2, they have like human readable names now, which is actually quite good. So now what we're going to do is actually create that longer form data frame that we're going to call RTs_long. Now, into that, we're going to need to take our df that we just had, but we need to use the pivot longer function. We saw earlier we used the pivot wider. We're going to use pivot longer. Okay. And again, our first argument is going to be what data set. So it's df. That's the one I just created with the new names. So we're going to pivot longer df. And what I need to do is tell it what my columns are going to be. So my columns that I'm going to pivot are going to be the control and caffeine. And no, I usually need to use a C in front of those. So columns equals concatenate, control, caffeine. I could have multiple columns, but that's okay. That's all I need. And then I need names to and then values to RT. So note, I'm going to put these in quotes. So what we're doing, I'll move this onto second line so you can see the whole thing. We're saying, I want to take pivot longer df, take these columns, control and caffeine, and I want the names that are inside of those, control or caffeine, to go into a new column called group. So it'll have, the group will be either call or control or caffeine, and the values will go into a new column that are going to be called RT. So essentially what this is doing is just it's reformatting this entire data set, right? So if we look at our data frame that we had for control and caffeine that's got these values, I'm going to actually have a new column called group and all of the values in one column. Watch how that works. So if I run that now, I've created a new object called RT's long. I'm going to look at that. Now we see we've got a column called group, and it's got control or caffeine in it, and the associated values with each of them. So what I've done is I've created this nice long format for R to be working in. Now, remember that we had just learned how to use the pipe operator, so we didn't have to do this intermediate step, right? So I could actually take all of this, start again, and I'm going to say, okay, I want to essentially do this in two steps. Into RT's longer, I want to rename RT's wide, and then pivot longer these columns. So essentially, I'm just doing this all in one step instead. So if I run that, we should see that my RT's long basically looks like the exact same thing as I just did in the last one. So like I said, we can use the pipe operator to just do all of this in one step instead of two. Now, once I've got this data set, maybe I want to actually save it, right? And actually save it so I can open it up later again without having to do all of this. And remember, we had used, in order to get data in, we used read CSV. Well, in fact, to export data, we can use write.csv. And all I need to do is tell it what I want to write. It's going to write RT's underscore long, and it's going to go to data slash RT's underscore long dot CSV and close bracket. So if I run that command, I should be able to look into my data folder, which is down here behind me, and I should be able to see now that I've got a file called rtslong.csv. So that's great. That is now exactly what I wanted. And I've saved my data into my actual data folder, the one that I've actually just been able to pivot into that longer file format. Let's go through one more quick example. So let's get a data file called core_t_wide. So it's core_t_wide. And into that, I'm going to read.csv core_t_wide.csv. Whoa, except that is in data, in quotation marks, /core_t_wide dot. Wow, I'm making a lot of mistakes here. CSV. Okay, so that should work. So read.csv core_t_wide strings as factors equals true. So we should see now that we've got the core_t_wide dataset up here. Again, you should find that linked. If I open that up, what we see is we've got an ID, we've got sex, and we've got core temperature at various times. Minute 0, minute 10, minute 30, minute 50, and end. So in the same way, we want to actually create just a core temperature and each one of these being a time. So we just want now two columns, one that's time and the other one that's temperature for each ID and sex. So we're going to find out how we do that. So think about how you might do that, and then we'll go through how I'm going to do that. So the first thing I'm going to do is I'm going to say core_t_ now long format. And into that, I'm going to now take core_t_wide, but I'm going to do something. Core_t_wide, I'm going to take core_t_wide, and then I'm going to pivot longer. And now I need to specify the things that I need. So my columns equals C. If I look at the columns that I need from the wide, it's going to be min 0, min 10, min 30, min 50, and end. But instead of having to write all of those out, I can actually use the same strategy that I did in the previous video. So little c, it's going to be min 0 using the colon through, so using all of them through end. Okay. And then the next part that I need, if we look at this, I need names 2 equals, and I'm going to call this time. And I'm going to go values 2, and I'm going to call this temp. Okay, and that should basically do it. So I should be able to get now a core_t long that should show up here. If I control enter, looks good. We can see now this has been divided up, so I actually have 1, 2, 3, 4, 5 values for each subject that are min 0, min 10, minute 30, minute 50, and end. And then for subject 2, minute 0, minute 10, minute 30, minute 50, and end. Right? So this is really like a nice long data format for me to actually do a comparison by time if I want to. And then again, I could do the same thing and write that file if I want to save it later. All right, so hopefully that video has given you a really good idea of how you use the pipe operator and how we can use the pivoting functions that are built into the Tidyverse and dplyr to start to rearrange your data to make it long format when you need that, or maybe a little wider format when you need that. Now, these can be used in much more complex ways, but I'm going to leave that up to you. Once you've got the basics of how to do that, you can then search on the web for your specific situation or even there's other YouTube videos that you might want to check out that are specific to being able to pivot a bunch of different variables. If you need to pivot more than 2 variables, then it starts to become a little bit complex. You might have to do it in steps. But otherwise, that gives you an intro to both pipe operator and to pivoting. All right, I'll see you next time.